Welcome to the math record. Today I'll be covering integration by parts. So first off, what is integration by parts? Well, basically it's just the integral version of the derivative product rule. So the derivative for the product rule for the derivative is that if we have two functions multiply to each other and we take the derivative of that, it's the same thing as taking the derivative of the first one, keep the second one the same, plus keep the first one the same, times the derivative of the second one. Okay, so what we're going to do is that we're going to isolate one of these variables. So I'm going to isolate this one. So that's going to be f of x times the derivative of g of x. And that'll be equal to, and then we're going to have to combine these two together. So we're going to subtract them. So that means f of x times g of x, the derivative of that whole thing, minus the derivative of f times g of x. Okay, so we know that's true because we just rewritten this form in a different way. And then we're going to take the integral of both sides in respect to x. So the integral of this, where we go, we just leave it alone. And when we have two things subtracted, we just do them individually. So the integral of a derivative, that cancel each other's out. So all we have is f of x times g of x minus the integral of this. Okay, so basically, if we're given two functions, f of x and the derivative of g, but just think about it as just a function. Don't worry at the notation. So when we have a function, we keep the first one the same. So this is our integration by parts. We keep the first one the same. And then our second one becomes, we find the integral because we work from the derivative to the integral. And then the first one, we take the derivative. And then our second one, we need to take the integral. So the first one we need to take, we leave it the same. The second one, we take the integral, multiply them each other, minus the integral of the derivative of the first one, and then integral of the second one, which we already calculated right here. So this is like a mnemonic to kind of remember it. Okay, I'm going to leave this up because we're going to try an example. So let's say we want to find the integral of x times natural log of x dx. Okay, so we need to take derivatives and integral. So which one is the easier derivative? Obviously this one, but it depends on which one you want to do. But what about the integral? Which one is easier? Well, obviously this one is easier. The integral of this is a lot harder. So we're going to make this one the integral that we're going to do, and this one the derivative one we're going to do. So we're going to rearrange this to natural log of x times x dx. So then we can work with this as our integral and this one as our derivative. Okay, so that means the integral of our first one, we need to leave it the same, right? Our mnemonic, SIDI. So same, integral, derivative, integral. So the integral of x is x squared. The derivative of x squared is 2x. We want x, not 2x, so we scale by 1/2. Minus, remember our integral, minus our integral. And then we do the derivative. So derivative of natural log of x is 1 over x. The integral of x, as we did before, 1/2 x squared dx. So I'm going to rewrite this so it looks a little bit nicer. And then minus, we have 1/2, move that to the outside. 1 over x times x squared is x, so the integral of x dx. Well, we know what the integral of x dx is. We already did it. That's 1/2 x squared. So we have 1/2 x squared times natural log of x. 1/2 x squared times this 1/2 is 1/4 x squared. And remember, there's no numbers here, so we're going to have to add our constant c. So that's our integral. So the integral of x times natural log of x is 1/2 x squared times natural log of x minus 1/4 x squared plus c. Okay, so that seems like another memorizing, and it might be a bit confusing. So an easier way to organize this is that there's something called the tabular method, which is basically integration by parts, but now we're going to do it with a chart. So it's with 3 columns. The first column is going to keep track of your sine. The second one is going to keep track of your derivative, which I just labeled as d for derivative. And the third one is going to keep track of your integral. Okay, so let's go back to our example again. So x times, oh sorry, the integral of x times natural log of x. So which one, so the way to do this, forgetting everything that we just did before, um, which one is easier to take the derivative of, and which one is easier to take the integral of? With the easier derivative of natural log of x, so that leaves x as going to be our integral. And the method for this is that we're going to keep writing terms, basically, etc. And we keep going on. So basically, every single time we're going to do this, when we take the derivative on this side and we take the integral on this side, we're going to multiply anything like this goes down. So it's got to be one term down on the second column. And we're going to keep multiplying those, and we're going to add all those terms together. So we multiply these two, add it to these two, add it to these two, add it to these two, until finally we get to a point where these two multiplied is really easy to take the integral of. Okay, so from here, let's just do our example. So the derivative of natural log of x is 1 over x. The integral of x, as we did before, was 1/2 x squared. Or as we do it again, we have 1/2. Derivative of this is 2x. So then we need to scale it by 1/2. Right? So the first one, the sign always goes from positive, negative, positive, negative, positive, negative. So it's always going to alternate. The first one always starts with a positive, and then we go to a negative. Okay, so starting from here, you're always going to have to check the row that you currently made and see if it's easier to do. So 1 over x times 1/2 x squared, that seems pretty easy, so let's stop there. So the first one is this. So natural log of x times 1/2 x squared. So 1/2 x squared times natural log of x. And then this one, it's a minus sign. So we have a minus integral 1 over x times 1/2 times x squared. So that's 1/2 x dx. Okay, so the integral of this is 1/2 x squared minus times 1/2 x minus 1/2 integral of x dx. This was 1/2 x squared as we did before. So 1/2 x squared times 1/2 is 1/4 x squared. And then remember to add a c. So as you see, this was much easier to understand and much faster. So this method is really reliable when you need to do integration by parts, like a repeated amount of times. So let's try an example of that. So let's say we have x squared times sine of x. We want to take the integral of this. Okay, let's delete the things from our chart. So which one is easier to take the derivative of and which one is easier to take the integral? Well, both of them are pretty easy, but usually we'll want to bring the thing down. So the derivative, let's bring this one down. So let's say that's x, because when we bring this up, we're going to deal with higher powers multiplied to some kind of trig. So that's not going to be good. So the derivative is going to be x squared, and our integral is going to be our sine. Okay, the derivative of x squared is 2x. The integral of sine of x, so we got to think about opposite. So the derivative of cosine is negative sine. So that means the integral of sine will be the negative version of our cosine. So negative cosine. Okay, now the derivative of 2x is 2, the positive sign. So the integral of negative cosine of x is going to be sine, negative sine, because the derivative of sine is cosine. So we have a negative here to make negative cosine. Okay, so from here, we could probably stop because 2 times negative 2 sine of x, that's easy to take the integral of. So we're going to have the first one, our second one, and this is going to be our integral. Okay, so that would be x squared times negative cosine of x. So cosine of x. And then the second one is this, 2x times negative sine of x. Remember this row is going to be negative, so multiply by negative. So that'll be a plus 2x sine of x. And then our last one is this one. So we have a positive integral. So positive, yes, this is positive. So positive integral of negative 2 sine of x dx. So let's move the negative 2 to the outside. So minus 2 integral sine x dx. And we already know this, the integral of sine x dx is negative cosine of x. So raw, we have negative x squared cosine x plus 2x sine of x. And then negative 2 times negative cosine of x is plus 2 cosine of x. And then we add a c. So that means the integral of x squared times sine of x dx, is equal to negative x squared cosine x plus 2x sine of x plus 2 cosine of x plus c. Okay, now let's do one more example, which I think is a really interesting case to think about. Okay, let's delete this. Okay, and this one is going to be the integral of e to the x, actually say e to 2x cosine of x. So when we do the derivative of these become sine, cosine, and they repeat over like that. And the derivative of this always stays the same. So there might be a way to solve this, even though it kind of seems like it's going to repeat for infinity. So the integral and the derivative, they both seems pretty easy. So let's just choose one for the other. Let's just do the derivative for our cosine because it's easier to do, and our integral for this. Okay, so what's the integral of this? Well, remember the derivative of a exponential stays the same, but remember there's 2x inside, so we need to chain it. So there's going to be a 1/2, because the derivative of this will be 1/2. Leave it outside as a scalar. Derivative of e 2x is 2 times e to 2x, so that cancels out. Okay, so the derivative of this is negative sine of x. Okay, now let's do this derivative again. That's negative cosine of x. And when we do the integral of this, 1/2 times another 1/2 is 1/4, e to 2x. Okay, so that gets pretty interesting because if we think about this, look at this. When we multiply together and we take the integral, that's cosine and e to 2x. Cosine e to 2x. So it seems like it just repeats. So what we could do is that we could label the integral of this, we could label that, let's say, as, let's say, a, capital A, and that would equal to cosine of x times 1/2 e to 2x. So 1/2 e to 2x times cosine of x. And then negative sine of x times 1/4 e to 2x times that negative, so it's positive. So plus 1/4 e 2x sine of x. And the last one, we take the integral of this with the positive, so that stays negative. And then since this and these are scalars, we just move that aside. So positive times that negative makes a negative. Negative 1/4 and integral e to the power of 2x times that cosine. And we know what this is. That's a, because that's what we labeled this integral as. So we substitute this with an a. And now we just need to solve for it. So 1/4 plus 1a plus 1/4 a is 5/4 a equals 1/2 e 2x times cosine x plus 1/4 e to 2x sine x. And then multiply by 4 or 5 to both sides, so we get a. 4 or 5 times 1/2 is 2 or 5 cosine of x. 4 or 5 times 1 over 4 is going to be 1 over 5 e to 2x sine of x. That means the integral of e to the power 2x times cosine of x, let's add our c, is equal to 2 over 5 e to the power 2x cosine of x plus 1 over 5 e to the power 2x sine of x plus c. And that basically covers everything for integration by parts. Thanks for watching, and in the next video, I'll be covering integration by partial fractions.